Now that we know a little bit about some different values, measures of center and variation, as well as how to make some pictures using bar and pi, that's for qualitative data. We're going to work more with quantitative data and looking at when I make a stem and leaf plot, when I make a histogram, what's happening in terms of that data? How does it look if I was to step back and look at a picture of the data as if it was completely filled in? I have infinite number of values that I've plotted. The uniform data set says from maybe I started from 1 to 5. There was uniformly the same amount in every number between 1 and 5, so it forms a rectangle. In data that is skewed right, we always kind of draw this little baseline, such as a number line. Skewed right means that some values are going to be far on the right. And a lot of people say skewed right means the tail is on the right. You can think of it as that, but we want to know why. What does this mean? Why would we call it skewed right? Well, when we talked about measures of center, we like to think is our mean and our median at the same location. We call that normal. Normal looks like this. And right here is our mean, which now we're calling x bar, and our median. They're both at the top, and actually our mode is there too. The highest, the most occurs right there in the center. So when I look at skewed right, it doesn't follow that. So what happens is that there is an outlier, a very large number. And when I add a bunch of numbers together and then all of a sudden add a very large number to it, what happens is that maybe right here I'm just kind of eyeballing, that's my median. What happens to my mean? Well, this outlier increases the sum or the total of the values. Therefore, when I divide, I'm getting a larger number. So that outlier pulled my mean, and maybe right here, and again, I'm just eyeballing. I'm not sure exactly where it is, but it's pulling the mean to the right of the median because of that big outlier. So if I have a graph that is skewed left, again, we kind of start with this baseline. I have a tail and then a big peak. And so what's happened here is my median. We abbreviate usually MED. And what happened is this outlier, this value way down here are very small. And so what happens is that it pulls my mean away from my median, and we call that to the left. So we have things that are skewed right and skewed left, and it's all based upon the position of my mean and my median. You need to also know why we call them skewed right. My mean is pulled to the right because of an outlier. A big number made my mean a larger total. Thus, when I divided, I got a larger value than my median. If you look at normal, what we're going to be working with here lately or soon, this normal distribution is what we call symmetric. So there's as many big as there are small, and so they offset each other. We have another graph that we're really not going to look at. It's called bimodal, and what that does, it's got kind of these 2 peaks or 3 peaks. Bi means 2, so we'll just stay with 2. Mode, remember we don't use the mode very often, but we like to look at bimodal to see kind of what's going on. So these are just pictures of the overall distribution, and then we'll be working specifically with the normal distribution.